Alright you guys, let's implement the pseudocode from the previous video. So make sure in your terminal you are cd'd into the course directory, into exercises, and you will run just lc3 length of longest substring -- watch. This will run our test suite. Test will fail as expected. So let's implement the pseudocode and make our test pass. I'll create a variable called window chars map and set that to an empty JavaScript object, and this will contain all the characters in the input string and the earliest index they can be found. Now I'll say let window start. So this will have the index of where a window starts, and it will start at 0 at first. And I'll say let max length equal to 0. So this is what our function will return, because we want to return the maximum length of the longest substring in our input string, and we're going to update this variable in our for loop. So let's iterate through the input string. For let I is equal to 0, I is less than s.length, I++. I'm going to call the current character we are on nchar, because remember that our for loop is always the end of the window, so the current character we're on could be considered the end character. So I'll call it, and that's going to be set to s at index I. Now, let's make sure that our current end character, or the current character we are on, has not already been found in our sliding window. So I'll say if window chars map, nchar, we're going to get an index back from that. If that's greater than or equal to the index of, which is window start, the index of our window start, then there's a duplicate value found. We did greater than or equals to because if this was less than window start, it would not have been our window in the first place. So that's why I did greater than or equals to. So duplicate character has been found in our window. So we have to update window start from our pseudocode, right? Window start is equal to window chars map and chars. So we grab the index of where it was previously found, and we set window start to be one above that index. Now I'll say window chars map nchar is equal to I. So we're going to update this. So as our window increases, we want to put our current end character into here. And of course, if a duplicate value was found from before, then this code would also update the new position of that previously it was a duplicated character in our window. I hope that makes sense. Then, now that these two chunks of code have made sure that our window has unique characters only, let's update max length. I'll say max length is whichever is bigger. The previous max length, that should be math.max, the previous max length, or the length of our current sliding window. So remember, the end of our window is where we are on in our for loop. So I'll say I, this is the end of the window, minus window start. But remember that array indices start at 0. So we're going to add 1 to compensate. This for loop, after it runs, max length will be accurate. So we're going to turn max length. Save. And our test pass. So now let's make sure that our code also passes the leet code test. So I'm going to copy it, head over to leet code, paste it in, and our test pass. So what's the complexity analysis for a length of longest substring? Time complexity is O of n. Each character of the string, the input string, only needs to be visited once, because of our sliding window approach. If we had used nested for loops, this would be n cubed, which is pretty terrible. And the space complexity is O of whichever is smaller, m or n, because the number of keys in our window chars map here, the number of key value pairs, is bounded by the size of the string n and the size of the char set alphabet m. Now from what I've seen in the leet code test, all the input strings they only contain the characters A through Z, so m will always be 26. But let's say your char set has unique characters like asterisk, the dollar symbol, pound, then m would be the size of your custom char set. Alright you guys, that concludes this video.